For almost as long as we've understood what energy even is, we've dreamt of harnessing the ultimate power source, our sun. It's an incredible story, full of brilliant minds, some pretty bizarre inventions, and a scientific mystery that actually took an Einstein to solve. So let's get into it. This is the history of solar energy.
For literally all of human history, that star in the sky was a source of heat and light, right? But the idea of turning it directly into power, well, that felt like pure magic. So how on earth did we figure out how to take the raw thermonuclear power of the sun
and channel it into clean, silent electricity using these things? Well, that whole journey begins not with some huge explosion, but with a quiet, curious observation in a 19th century French lab. Way before solar panels were a common sight, visionaries of the industrial age were already trying to catch the sun. They really saw a future powered by its limitless energy, and they built some truly incredible, almost steampunk-like machines to try and make it happen.
So the first clue has kind of emerged piece by piece. It all started back in 1839 when a young Edmund Becquerel noticed that light itself could create a tiny electric current. He called it the photovoltaic effect. Then decades later, another breakthrough. The element selenium was found to be light-sensitive, and that led an inventor named Charles Fritts to build the world's very first rooftop solar array in New York City in 1883. Now, it was incredibly inefficient, we're talking less than 1%, but it proved the concept was actually possible.
But maybe the most ambitious early pioneer was a French math teacher, of all people, named Augustin Mouchot. This is back in the 1860s, long before climate change was on anyone's radar. And he was already deeply worried that France's reliance on coal just wasn't sustainable. So he turned to the sun for an answer.
And Mouchot's genius was on full display at the 1878 Paris World's Fair. He unveiled his masterpiece, this massive solar concentrator. His sun engine used a giant mirror to focus sunlight, boil water, and drive a steam engine, which in turn powered a refrigeration unit. And it worked. I mean, think about that. He made a block of ice using the power of the sun. The crowds were absolutely blown away.
But Mouchot's timing couldn't have been worse, because at that very same fair, the internal combustion engine was also making its big debut. With coal and oil getting cheaper and more abundant by the day, the world basically chose fossil fuels. Mouchot's government funding was cut, and just like that, the solar dream went dormant for decades.
See, the big problem was, nobody really understood how light could create electricity. Those early inventions were all based on just observation, not deep theory. To truly move forward, science couldn't just build better machines. It had to unlock a fundamental secret of the universe.
And that secret was hidden inside something called the photoelectric effect. Scientists knew that if you shined a light on certain metals, electrons would just fly off. But they had no idea why. It was a real head-scratcher that defied all the known laws of physics at the time. This led to a huge clash of ideas. See, classical physics said light is a wave, so a brighter, more intense light wave should have hit the electrons harder, giving them more energy. But experiments kept showing that just wasn't true. Then, in 1905, a young Albert Einstein comes along and proposes this radical idea. What if light isn't just a wave, but it's also a particle? He called these particles photons, and he argued their energy was all about their color, their frequency, not their brightness.
And here's the key takeaway. A single photon of blue light had more energy to give an electron than a photon of red light, no matter how bright you made that red light. This explanation didn't just perfectly solve the mystery and lay the groundwork for all of quantum mechanics, it is the fundamental scientific principle that makes every single modern solar panel work. And that is what won Einstein his Nobel Prize in 1921. Not relativity, but for unlocking the secret of solar power.
So, with the theory finally in place, the stage was set for the next giant leap. The world just needed the right material and the right team. And that moment came, almost by accident, in a place basically dedicated to inventing the future, Bell Labs.
In the early 1950s, you had this team of researchers, Chapin, Fuller, and Pearson, and they were investigating silicon for new electronics. While they were experimenting, they found that if they added specific impurities to pure silicon, it suddenly became incredibly sensitive to sunlight. They had stumbled onto the key. On April 25, 1954, they showed off their invention by powering a little toy windmill, and in that moment, they changed the world.
The Bell Labs silicon cell hit an efficiency of 6%.
Now, that might not sound like a lot today, but compared to the less than 1% attempts from the 1800s, it was a quantum leap. This wasn't some lab curiosity anymore. This was the first truly practical solar cell.
And the world immediately got how huge this was. The New York Times reported that this could finally lead to the harnessing of the almost limitless energy of the sun. The dream of those 19th century pioneers was suddenly back, and this time it was backed by some serious modern science.
Okay, but having an invention is one thing. Turning it into a mainstream energy source that powers our lives, that's a whole other challenge. The next chapter of this story is all about taking this incredible tech from a super niche application and scaling it up for everyone.
And its first big break came from, well, literally out of this world. In 1958, just 4 years after it was invented, solar cells were powering the Vanguard 1 satellite in orbit. I mean, for a satellite, what could possibly be better than a power source that never ever runs out of fuel? The space race proves solar power's reliability, and it spurred crucial government investment into making the cells even better and stronger.
But there was one massive problem: the cost. Back in 1956, solar power was just astronomically expensive. We're talking around $300 for a single watt of power. It was great for satellites, but there was no way you were putting it on your house.
But over the next several decades, thanks to relentless innovation, that price just plummeted. Today, that same watt of solar power can cost as little as 50 cents. I mean, that is a staggering, mind-boggling drop, and it's what made the entire solar revolution possible.
The next big push came from a crisis right here on Earth. The oil shocks of the 1970s made everybody painfully aware of how dependent they were on fossil fuels. All of a sudden, solar energy wasn't just a neat idea, it felt like a matter of national security. The public got really engaged, with events like the first Sunday, and President Jimmy Carter famously installed solar panels right on the White House roof in 1979.
So you take that groundswell of interest, combine it with those falling costs and constantly improving technology, and it's brought us right here to today, to what a lot of people are calling the beginning of the solar century.
From those first tiny, inefficient selenium cells, we now have these massive solar farms stretching across deserts and fields, generating gigawatts of clean electricity. Solar isn't a niche player anymore. It's a mainstream global energy source that's growing like crazy.
It's been such an incredible journey, right? From a French teacher's fear of coal shortages and a patent clerk's revolutionary idea about light, to satellites circling the globe and now power for our entire planet, it just makes you wonder, what's next? What's going to be the next breakthrough in our timeless quest to harness the power of the sun?